Okay, with your quadratic formula, you have inside the root, you have this thing called b squared minus 4ac. This part inside of here is called the discriminant. And as its name implies, it will discriminate what your roots will be. It's pretty obvious here. If you're going to take the square root of something, then what's inside the square root will determine the nature of your roots. So in other words, if this b squared minus 4ac is negative, then you're going to have two imaginary roots, which are going to appear in conjugate pairs. So, because it's plus or minus, as you remember, you have minus b plus or minus, so whatever, all over 2a. So this part of the fraction will be the same if this is less than 0. And the only difference is it's plus or minus. So if b squared minus 4ac is less than 0, which is saying that it's negative, then two imaginary roots. Okay? Now if b squared minus 4ac is greater than 0, then you're going to get two real roots, two real unequal roots is what you're going to get. Now what happens if it's equal to 0? You're going to get a double root that's going to be the same root. So that would be, if you had 0 in there, you have a double root which would be the same. You're going to add or subtract 0 from this thing, minus b over 2a, so you're actually just going to have a double root, which is the same number, which will look like a single root to you, but it's really called a double root. Now the directions to this problem ask you to tell the nature of the roots without solving the equation. Once you put it in standard form, which means you have your square term, your linear term, your constant term all on the left equal to 0, then you can just pick out your coefficients. A here is 1. B is 3. And C is negative 9. And now all I have to do to determine the roots and what type of roots I'm going to have with this equation is just determine the discriminant, which is b squared minus 4ac. Well, b squared is 9, 3 squared is 9, minus 4 times 1, which is a, and c is negative 9, which is going to give me, this will be negative 36, so when I subtract negative 36, I'm going to really add 36, so I have 45. 45 is greater than 0, so I have two real unequal roots. And you can just write it like this. Again, this quadratic is already in standard form, so we don't have to do anything. So all we have to do is figure out b squared minus 4 times a times c. b is negative 8 now. When I square it, I get 64. Subtracting from that, 4 times 3, which is a, times negative 5, which is c. Well, this becomes negative 60, so when I subtract negative 60 from 64, I'm actually going to add 60, so I get 124. Again, greater than 0, two real unequal roots. Now here's a quadratic that they do not have in standard form, so you have to put it in standard form. You can't pick off the a, b's, and c's with it the way it is. You have to get everything on the left or the right and set it equal to 0. So let's just bring the z over here, so I have z squared minus z plus 5/4 equals 0. Now you might think that that fraction is going to give you problems, but believe me, it's not, because when you have a denominator of 4, you remember c is going to be multiplied by 4, so it'll clear the fraction so you don't have to worry about it. So if your denominator of your fraction is 4, just don't try to bother clearing it because it'll just give you bigger numbers in your A and your B, and you don't want that. So B squared is -1 squared is 1 minus 4 times A, which is 1, times 5/4, which is C, and the 4's here will cancel out, and I just get 1 minus 5, which is -4. Well, now I'm going to be, this discriminant is inside the radical with a negative sign, so I have two imaginary conjugate pairs. Actually, one imaginary conjugate pair. If I put pair there, you only have one here. Now you might be a little bit confused about this because the middle term in this is not there. So this is your C right here. -4√3 is C. B here is 0 because there is no x term, and A is √3. So now 0 squared is just 0 minus 4 times √3, which is A, times C, which is -4√3. Now I have √3 times √3 is just 3. -4, I'll put this in here. So I really have plus, because negative times negative is positive, and you get 16 times 3, which is 48. Greater than 0, 2 unequal roots.